applications, the first type of application that we're going to look at, so we do similar applications to what we do with one variable functions. Remember, way back in chapter 3, we did applications of marginal analysis and optimization. Same thing's going to be true with multivariable functions. We're going to do applications of marginal analysis and optimization. Alright, so first, marginal analysis. So remember, we can only look at one change. There's just two variables that could change. And so for the marginal analysis, we're going to look at the approximate change in either revenue, cost, or profit when we have a 1 unit increase in either the x or the y. It depends on which partial derivative I'm looking at. I can't do both. I can do both separately, but I can't do both at the same time. So either it's important that it's the or, right? One or the other. Alright, so the first example, which in the notes I've given you, I did it as a multiple choice question because I wanted to make sure that it was clearly written out and you could see the examples. The answer for the first one's C in your notes. But where C comes from is, alright, so I have my function f of x. It's a profit when they sell two different types of pools, alright? So the x represents one type and the y represents another, alright? So it's the profit in dollars. And so x represents the larger pools, the 24-foot pools, and y represents the smaller pools, the 18-foot pools. Alright, suppose this is what we get. F sub x, 500 for x, 120 for y, equals 1,500. Well, again, this is where the analysis part is the more important piece, right? I didn't make you find any derivative in this case. I want you to interpret. It's your interpretation of the marginal analysis. It's the analysis part, right? And so this part, there's three pieces to it. What's changing? By how much? What's being constant? At what value? And how is that affecting my overall function? So those are the three pieces. Alright, so first of all, the x values, what's changing? If we change the number of x, well, x represents 24, the bigger pools, from 500 to 501, and it's that specific one. If I had a different number, so if it went from 400 to 401, it would affect it differently. So it's important, from 500 to that additional 501st one, so if we sell that one more, and hold the sale of the 18-foot pools constant. And again, it's important that it's not just constant, but it's constant at what level? 120. It would be different if it was constant at 100 or 150. It's important that we're selling exactly 120 18-foot pools. So if that happens, I'm selling exactly 120 18-foot pools. I sell the one more, and the one more is going from 500 to 501. That one more sell, so that's one more in the bigger pools. Then profit will increase. There's an additional gain or increase in profit, however you want it. Profit will increase by about, and again it is an approximate, $1,500. Alright, so those are the three pieces we're looking at when you're, again, it's the analysis part of these that is just as important as the calc part. Because usually you plug these in a program and you get the numbers spit out at you. Alright, so this is the numbers that came out. So again, the three pieces that we're looking for. What's changing and where is it changing? What's being held constant and at what level is it being held constant? And how does that affect my overall function? Does it give it an increase, a decrease, and exactly how much does it, approximately how much does it increase and decrease? Alright, so the second example. Suppose we have a local hardware store that has two different kinds of hammers. The first brand sells for X dollars, so this is the price. Alright, so this would be a price demand function. So X is the dollar, the value of the first type of hammer. Y is the value of the second type of hammer, what they're selling it at, the price. The monthly profit in hundreds of dollars, I gotta remember it's in hundreds of dollars when I do my interpretation, is given by P of, again, I don't know what it is. What I know is the derivative at specific values. So it's P sub Y. When I plug in 27 for X and 10 for Y, it comes out negative 4.5. Alright, so what is that telling me? Alright, so first of all, what's changing? Alright, well the y value is changing. So what's the y value mean? So if they change the price of the second hammer specifically from, it was selling at a price of $10, so they raised the price of the second hammer. Alright, they're going to raise it from a $10 hammer to an $11 hammer. Right, that specific change. And hold the first hammer price constant. They don't change its price, they hold it constant, and it's constant specifically at $27. So not only are they holding it constant, but they're holding it constant at 27. They've set that price and it's staying that price. And it matters that it's $27. It would be different if it was 25, 26, 35, 27 is what matters. It's constant at that specific price. So if they increase the price of the hammer from $10 to $11, hold the other one constant at the 27 that it was already at, then profit is affected by a negative, and again, it is in hundreds of dollars. So then profit is, so the negative part, you don't put the negative part in your analysis. The negative is telling you profit's going down. Profit decreases by about 4,500, or I think it's easier to do 450. Alright, again, you don't put negative 450 in your description. The negative's taken care of by the word decreases. So they're losing profit if they increase the price of the cheaper hammer from 10 to 11, which means their sales are going to go down, right? Your prices go up, your sales go down. Alright, and so, again, those are the three important parts when we're doing the description. What's changing and what value is it changing at? What's being held constant at? What value is it being held constant at? How is it affecting my overall function? In this case, it's a loss of profit. Alright, we'll stop there. I'll pick up the next example in the next video.